Assalamualaikum. Hello everyone. Today we're going to learn organic chemistry. Okay, topic 6.1, which is on benzene. Okay, today very simple. It's just introductions and naming. Now let's take a look on the first one. What is benzene ring? Here it says that arenes are aromatic hydrocarbons containing one or more benzene rings. Hydrocarbon means contain only carbon and hydrogen, but since it has a benzene ring, you call it arenes. Now, another one, compounds of benzene are known as aryl compound or aromatic compound. So, for example, here you see that this is a benzene. This benzene contain only carbon and hydrogen. But since you have that chloro here, chlorine on top, you call it chlorobenzene. And this is an aryl or an aromatic compound because it contains that benzene. Next one, another name for benzene, instead of saying that this is benzol because it has the OH alcohol, you don't call it benzol. Instead, you call it phenol. We have this PHENYL, phenol. But since this is alcohol OH, you know that alcohol have that name ol at the end. Then you call it phenol. Not benzol. So reminder, it's not benzol, it's phenol. Okay, so here we have chlorobenzene because chlorine, it's chlorobenzene. Here, because you have that OH attached to your benzene, you call this thing phenol. Now, next one, we want to look further into where does this structures of benzene begins with. Now, Kikyols is a scientist who said that benzene has this structure where you have 6 carbon atoms and then 6 hydrogen atoms. Okay, and then here there is CC double bond. At the same time, there is also a CC single bond. So Kikyo suggests that this is the structures of benzene. Now, but the problem here is that, okay, if let's say you have this CC single bond and a CC double bond, sorry, and then a CC single bond, what happened is that here, since the CC double bond will be shorter, you can refer to your data booklet, look at the bond length, okay? The CC double bond will be shorter compared to a CC single bond. So in the end, instead of having a perfect hexagon that looks like this, it will be a distorted hexagonal shape. It will look like this because this one will be shorter compared to the CC single bond, isn't it? So another one also, scientists nowadays says that this is not the correct structure. This is not the correct structure. It shouldn't have that CC double bond. Reason why? When they try to react benzene with bromine, okay? Now, you see, Kikyo say benzene contain a double bond. So, if it contains a double bond, it should react like alkene. Okay, undergo the addition reaction like alkene. But the problem is that when you react alkene with bromine, okay, no need for heat, no need for catalyst, reaction will proceed. But the problem is when you have benzene, you react it with bromine, it requires a catalyst to proceed. If there's no catalyst, no reaction. So, indicating that benzene shouldn't have a CC double bond. Okay? So here, this is another formula for benzene, how it looks like. Nowadays, this is the structures of benzene that we used. Okay, you can see here will be carbon, this carbon also, this is carbon here also, and it's also attached to a hydrogen each. Okay, so remember the formula of benzene is C6H6, 6 carbon, 6 hydrogen. Okay, and this circle is not just simply a diagram there, no. This circle is actually, there is an electrons that keep on moving, delocalized here. Okay, there are 6 electrons altogether that move, okay, that form this ring. Okay, so here's the explanation. Now, It says here, each carbon atom in the hexagonal ring is sp2 hybridized. I hope that you still remember what is sp2 hybridization. If not, refer back to your notes on hybridization, sp2. Okay? So here, now, so in the sp2 hybridization, what happened? You look at this carbon that I highlight in red. Okay? This carbon, okay, it is bonded to another carbon. So you can see here one pair of electrons with one of its neighboring carbon. They share one pair of electrons between this carbon and the neighboring carbon. This is sigma bond, head-on overlapping. Okay, so this is a formations of sigma bond. Next one, another electrons from the carbon. Okay, it overlaps with the electrons, the orbital, the head-on overlappings with the hydrogen. Again, it will form a sigma bond. Okay, and there is also another, okay, head-on overlapping here between this carbon and the neighboring carbon. Again, it form another sigma bond. Okay, so I hope you recap. If you don't understand this, please refer back to your SP2 hybridization notes. Okay, now remember another one. Carbon will have 4 electrons, okay, that you can use for bonding. But here, you're only using 3 of it. One here, and one there. So, what happened to that 1 electrons? Okay, so this electron is the one, you can see here, each, okay, and 1 electron pair on each of the 6 carbon atoms contribute to the pi bond. Okay, so here you can see this is a p orbital overlapping. Okay, sideway overlapping, pi bond. Here also sideway overlapping, pi bond. Here also sideway overlapping, pi bond. But the problem here is that they don't just stay there. Okay, these electrons, these 6 electrons, they are free to move, forming a ring. Okay, so they are said to be delocalized. It means that they are free to move. Okay, so you can look here. Overlap of the p orbitals produce a ring of delocalized electrons. They are free to move above and below the planes of benzene's carbon atom. So it means that this p orbital above and below, kan? So this p, they will overlap, forming a pi bond above. Okay, and then they also overlap below, forming another ring below. So you can see here there's one above, one below. Okay, but remember there's only 6 electrons that keep on moving here, not 12. Not, it doesn't mean that above have 6, below have 6. No, this p and each only 1 electron, so together there are 6. It's just that they are forming ring on top, ring below, because of the sideway overlapping. Okay, now another one is that this benzene ring, this one, they are in planar. Okay, they are on a plane. So what happened is that the bond angle will be 120. Why is it 120? Look at this one. You see this carbon is only attached to 3 atoms. So if it is 3 atoms, this is what you call a trigonal planar. So trigonal planar has a bond angle of 120. Okay, so here the 3 bond angles around each of the sp2 hybridized carbon atoms are 120 degree. So that's all for benzene. The next one that we're gonna go through is the naming. Thank you.